everyone, welcome to Xiao Hei Classroom. In this section, we will introduce the use of A6 Servo Speed Mode. We mainly introduce from these aspects. The first is a brief introduction to the concept of speed mode. Next, we will introduce the specific use of communication speed mode, from hardware wiring to parameter configuration, configuration in the host computer software, and programming. Finally, we will introduce the configuration of some do signals commonly used in speed mode. Let's first look at the concept of speed mode. The speed mode refers to controlling the speed of machinery through speed commands. By giving speed commands with numerical values, the servo drive can achieve fast and precise control over the mechanical speed. Therefore, the speed mode is mainly used in situations where rotational speed needs to be controlled, such as analog engraving and milling machines, spindles in CNC machine tools, winding and unwinding equipment, etc. through speed control. The rotational speed of cutting tools or the feeding speed of workpieces can be precisely controlled to achieve high-precision machining operations. Below is the control block diagram of servo driving system. When using the speed mode, we first need to set it to 0 through the P to 0.00 parameter, and then select the speed control mode. And then we also need to select the source of the speed command through P for .000. So let's take a look at the use of communication speed mode in detail. The parameters related to the communication speed mode are listed here. If you use this mode to communicate, you can set the parameters according to this table. Multi-section operation can be selected through determinal. You can also select multi-stage. Then you can select the source of the speed command by selecting 1 to 4 as 0, or 1 through multiple instructions. With determinal control, in addition to configuring the function to the corresponding determinal, it is also necessary to select the effective logic level for each terminal. Here is the diagram of the servo and host computer software MagicWorks tuner, connecting through the Modbus serial port, and the servo hardware interface is RJ45. Here is the definition diagram of the RJ45 port pin. You can follow this diagram to make a cable. Then let's take a look at the programming in the host computer software. Take this Modbus RTU communication as an example to introduce. Use the CTH200 series PLC to control the A6 servo through the Modbus RTU to realize the function of speeding and returning to the original. Use Modbus RTU to control the servo and support the following function codes, such as function code hexadecimal 03 to read single or multiple drive parameter registers, 6 to write single drive registers, and 10 to write multiple drive parameter registers. Then, in addition to knowing the corresponding function code, we also need to know the Modbus address corresponding to the servo parameter address. The following formula can convert the servo parameter address to the Modbus address. For example, the parameter P3.002, the servo group number is 3, and the parameter number is 2. After entering the formula below, it is converted to the Modbus address. It is 3 times 256. Then add 2 and add 40,001. Finally, it is equal to 40,771. For parameter configuration, you can refer to the steps here. Next, you can use the Modbus to master library to program in the PLC to control the reading and writing of servo parameters. Multiple read and write blocks need to be pulled and triggered. For parameters that only need to be set once, they can be written directly through the panel. There are 2 Modbus to master libraries. You need to select the correct library instructions according to the port of the PLC you use. Then the library contains two instructions. Through this modbus_CTRLL, the master station can be initialized, and parameters such as baud rate and verification of communication can be set. The next instruction is the polling trigger for parameter reading and writing, which realizes the reading and writing of servo parameters. Here, the parameter address has been converted to the corresponding Modbus address. These two write operations enable the servo and write the given speed to the servo. Here is the acceleration and deceleration time written to the drive. Here are the parameters of reading the servo drive. This is the DIPIN configuration table, which DIPIN configuration function needs to be given. Write the value of the corresponding function to the parameter address, corresponding to the corresponding DI. Then here is the configuration table of the do pin. Which function you need can directly write the value of the corresponding function to the parameter address corresponding to the do. Here are the wiring diagrams of the digital input and digital output circuits. The input supports NPN and PNP types, and the output only supports NPN types. That's all. Thanks for watching.